Good evening, heroes and heroines, and welcome to Practising Programming in C with Miblo. So yeah, what are we doing? We are today going back to do the BWT and RLE stuff. So we'd finished PPIC lessons, and we are just nipping back to the compression stuff for a second, just to finish off that before moving on to pastures new, which we don't know yet. So let me just get some music on. I really don't know how long this will take actually as well, because I mean it could be a really quick one, or it could take 2 hours like usual. World of Goo, Organ Trail. What else have we got? Have I got the Stanley Parable music? I wonder. No, I think I've got the Beginner's Guide though. Yeah. Okay, let's go with this. This is 42 minutes. Okay. So now we currently have me live, John live, and William live. Amazing. Where am I going? Here, right, yeah. And is 4K still open? No, it isn't. Wow. So, we do T. And also, it did occur to me that this is more than BWT now. It's kind of run length encoding and Burroughs Wheeler transform. So I'm thinking I might make a different file name for it. So yeah, let me just copy. I'm going to copy bwt.c, and I'm just going to call it is it MZ or M? Yeah, mz.c for like Miblo zip. And then I should be able to find that here. If I build this with a bit of luck to do, yeah, brilliant. Right, that was interesting. What did that do? Oh, hang on a minute, what did I just try and run that on? Oh, test corpus. And test corpus is the thing that's like 2 gig, isn't it? Oh no. What is 91 kilobytes. What was it? BWT corpus was the thing that I was actually using. Right. That's more like it. So yeah. Excuse me while I blow my nose. No drop frames. 5 minutes in. I suppose I could have been a bit more productive in those 5 minutes. Let's see. So we've got these printouts going on. Gosh. Bless me. Okay. So let's just comment out the other printfs. How do we do that? Right, it's just these. So I should just print the one thing, yeah. So if I pipe this to xxd, what does that give me? It gives me an unencoded string. And then the 3A, well actually let's just take out the start of the print. So it's printed out this. And it's got the new line at the end. Right. So I did actually look back at one of the videos I'd done previously on the RLE. And I saw how I was iterating through this loop. So rather than having like a separate I to just literally do the iteration, I did I used the pointers at the like the in pointer and the in buffer. I used the pointers for those to calculate how far I can go, and it was as a while. So it was while in buffer. Sorry, in pointer take away in buffer. While that's less than the in size, you do this. So now I just need to somehow get this stuff working. I suppose I could do this. So that's going to be set to that. And then increment the in pointer maybe. No, that doesn't feel right at all, because you might as well do it all in the loop. You know, so at best you might as well do this sort of a thing. And then you come into the loop. Go into the loop and you say token is equal to the value at in pointer, and then increment the in point. Oh, actually, no, it wasn't. You just increment the in point at the end. And if you're gonna do that, it's like, maybe it is okay to do it in here actually. Do it above. Token sets the in pointer. Yeah, and I suppose you could set the RLE point, the value at RLE pointer to be equal to the value of the token. Well, it's equal to the token. So then if the it's if the value of the if the token is equal to the end pointer. Do we want to increase the counts? And at the end, and after this else, you want to then, you know, plus the in pointer. Increase the count. Have I set, yeah, I have set that. So we could do is set in hourly points plus plus to be equal to the token. So it sets the first thing. And then increments, so it's ready to take another value. So if the token is equal to the value at the in pointer, we want to increase the counts. Otherwise, I mean, it's kind of like if the token is equal to the point, equal to the in pointer, then we do like RLE pointer plus plus is equal to the count plus plus. So that will set like the second value in the RLE buffer to be the count. Oh, hang on, and it's not incrementing because I actually want to do it each time through. Hello, Asaf. It's going very well. Just trying to get this logic down, so I'm actually writing out the RLE properly. Yeah. So the RLE pointer equals count plus plus. And then, if it isn't, I've tried it manually. I haven't actually, no. Yeah, it's a good idea actually. Let's see. So let's say I've got the string. Let's take. Well, I can't. Can I get the string? Let's say I've got the string NHHAE NNA sub. So let's say I've got that string. Basically, what I want this to do is to output NH1 AE dash N. Well, hang on. It's not actually one. It's actually like 128. Or yeah, it's 128. Right. And then AE. And then another 128. Bit unfortunate that it's like not going to line up. Okay. So, yeah. So I basically want this, I think. I wanted to output this sort of stuff. So in the else case, count does have to return back to 128. So I'm going to come into this buffer, and I'm going to first of all set the token to equal to the in pointer. So if we're saying like in buffer is equal to that, and RLA buffer is equal to this. And the hourly pointer is at the start of the hourly buffer. So I want to come into the in buffer. I want to set this guy as the token. I mean, I suppose I could. Yeah, I'm not sure if I can just set it directly into the hourly buffer. I mean, that is possible, I suppose. Let's see how that would look, actually. I probably could, actually, because it's just an offset. So come into the in buffer, and I'll set the hourly buffer to be equal. So the value, well, it's actually the value of the hourly pointer plus plus to be equal to the n. To be equal to the value of the in pointer. Increment the in, well, increment the in pointer. I mean, I'm incrementing that to the bottom here, so. Yeah, let's say we'll set the hourly buffer to be equal to n, and then increment the hourly buffer, and then we could say, if the value at the in pointer and the hourly buffer minus 1, if they match, then we want to increment the pointer. I think you should implement output car and each car functions to avoid having to deal with incrementing the pointers all the time. Wow, okay. Right. Output car. So, output car and car. So, yeah. If you're supposed to output, then you then you take in the car and return it, I presume. Otherwise, eat car would be you take in the car and return nothing. Or rather, you output car would read in a car from a buffer, and then put it into the buffer. Apple car, buffer pointer, unsigned car, C. So it's going to read from what right C to equal position. E car, choose a current car. Advances buffer pointer. This is going to increase buffer pointer. Output car. So E car returns a car and advances buffer pointer. So it returns a car. And it takes a string, which is a buffer pointer. Oh, it takes a pointer to a buffer. Sorry, it's gonna be got a car because they are cars. Returns the car and advances buffer pointer. I mean, I'm not sure why this helps. Yeah, I mean, I'm doing, well, not really doing that there. Am I doing anyone? Presume that's right, what eCal was like. An output car. I need another star in there. When you pass to it, it will only increment the local copy that it has. Ah. Okay. An output car. It writes the character car, the character C to the current position and increments buffer pointer. Current position. So this is Change the current count as a buffer pointer. We need to write it as. I'm not sure what we're do otherwise. Okay. So this is like a pointer to pointer. So this is a pointer to a car. And then this thing out here is a pointer to that pointer, and it's incrementing that pointer. Or does your car result is equal to pointer equals source. Okay, so we're setting the car result going to be equal to the thing we pass in. Increment the buffer pointer, and then return the result. Okay. Buffer pre plus. Okay. And then the output car. The output car writes C to the composition and increments buffer pointer. Writes C to the current position. So it takes in the car C. And also buffer pointer. Right, see to the composition equals buffer pointer. Just gonna increment buffer pointer. Well, it's probably the same syntax, isn't it? It's got to return C, maybe? Maybe that's right, I don't know. And the other thing... Output car and car. You don't really need to return it from output car. Okay. So what does it do? Writes C to the current position and increments buffer pointer. So he's saying that like buffer pointer plus plus is equal to C. Taking in double. It's not an equal. It's not that. It's not that at all. It's sorry. God said it to see it. Yeah. Okay. Equal to car. So if they're the same, that's pretty much it. So the thing is here, if I do this, I won't be able to increment the pointer there. I'm going to set that to be equal to the count, and I presume in this case I want to call eat car on the in pointer. How do I pass this now? What is it taking again? It's a buffer pointer. I just have to get the address. Yeah. Otherwise, if these guys don't match, then we want to output car. So yeah, it's like, so outputting a car to the RLE pointer. So we need to have we need to have incremented the RLE pointer. I want to output car to the RLE pointer. And it's the value in the in pointer. What's happening here? In pointer. Equal to the in pointer. I'm probably, what am I doing actually? Am I incrementing the in pointer too many times now? In pointer equate in buffer is less than the in size. That should keep me within the bounds. Should introduce more variables. Car in car is equal to in car. Do that once per loop. call it token as well. I mean, is that actually what it is? Car. And not have to worry about in point anymore. So look at almost left. Oh right, it's probably this, isn't it? Because we're at the start of the hourly buffer. Should be at the hourly pointer. We have incremented we've set the hourly pointer, we've incremented the hourly pointer. It's equals token. What is token now? Oh, token is, oh my god, token is an in pointer. Right. Try to do my own again now that you have eaten output car. So output car. So we're going to come in to the in buffer. The in buffer is equal to that. First thing I want to do is say in car. We're going to, you said to eat car, didn't you? Is that right? Yeah, car and cars eat car and in pointer. But if in car is the in pointer. Yeah, but then again, like if if I'm not going to use the oh, hang on a minute, what is it doing again? Buffer pointer. Output car. I think I'm gonna have to I'm gonna have to run these and just see. I just don't understand what they're doing at all. It's like avoid output car. So output car is taking car star buffer inside car. So it's like, so it's something like that. There's a character. Say the character is equal to this. Yeah, but this isn't gonna. It's not gonna return it. Eat car. Sorry, yeah, it's What am I actually trying to look at now? Output car. Let's try that. Yeah. Could do with being able to step somewhere. Oh, actually, no, I can break on that line and then just step through, can't I? So run to here. Output car. So go into output car. So it's taking the string. So what is the string at this point? Oh. Oh right, I need to malloc it. Oh, I should free it as well. Oh, I've lost the scope. So... Oh, it's another deadly signal. So what am I supposed to be passing to this? Eat car. So I'm supposed to be passing the address of the hourly pointer. So I'm passing the address of the string. And the hourly pointer was a pointer. So it was the same thing as this. Well, I can't do that actually, can I? I need to do... No comment the string to the buffer, you're replacing the buffer with the string. No comment replacing the buffer with the string. Not copying the string to the buffer. You're replacing the buffer with the string. Right? Yeah. Oh, it didn't go into the function. Copy the string to the... So I'm calling output car. String is changed, doesn't copy that value into your malloc buffer. It changes the address string is pointing to from your buffer to the subject string checking. Oh, right. Oh, sorry, I see. Right. Yeah, oh god, yeah, so I need to, yeah, I need to actually write into this. Yeah, sorry. Yeah, I need to write into the string a character at a time, don't I? Yeah. What am I trying to do here, anyway? I'm trying to understand what output car does, aren't I? Buffer pointer, unsigned car C. Like, so, if, I'm understanding this correctly, right? Basically, all this is doing is sort of saying, say like that I pass this to the, so like I pass this and that to this guy, is all this function does is doing in pointer plus plus is equal to C. I'm just not sure. I'm understanding what's going on at all here. And also, it's not really it's buffer pointer. I mean, yeah, maybe there's the buffer pointer. And then eat car. See the results. Well, hang on a second. Result is equal to pointer to a buffer pointer. Hang on, eat car looks very similar as well. That's what it does, you do a silo constants of pointers. Okay. I mean, I feel like I kind of do understand this. So now I have the constant output character to buffer and it's all wrapped up in an easy to use function. Outputting characters to a buffer. Well, I don't know, like I mean, so to do the same thing with the function, I need to kind of type car that. And I mean, the reason that I wanted to do this bit here was that I did want to keep spinning on the same address. I did want to keep spinning on the same address. I don't know if that's the right way to do it though. I don't know if I should actually write directly to the address as I go, or whether I should count up the counter and then only later on actually write it to the address. So okay, so that's the output car. And the I mean, when I was looking at the eat car, that also did look like it's doing the same thing. But it can't be. Car result is equal to the value at a pointer to buffer pointer. You can have car to write and rewrite that as many times as you need. You're trouble, right? Just the buffer the function. Okay, car to write. Rewrite. And then we go to output. Right, I see, yeah. Yeah, so maybe I should do that. But then, yeah, okay, so let me just understand eat car then. So, this returns a car. It's going to... Well, hang on a minute. Why does this have to return anything? Hang on a minute, is that correct? You know, I'm kind of saying like... Because in what situation would you want it to return to you? I suppose if you wanted to print F, what character was eaten? Because like the situation is... The situation is that you want to eat car here, right? And this isn't setting anything, it's literally... Well, hang on, is it even valid? It's a confusing metaphor. The idea is that if you have a buffer, you can call this function n times with a percent buffer pointer. And to return consecutive characters from the buffer. Check consecutive characters from the buffer. Okay. It'll return it. So I suppose in that case... Return it. Because like in the... In this case I don't want to write the value at in point... yeah, I don't want to write the value at in pointer anywhere. I just want to increment the... I just want to do this, basically. So I'm kind of doing this. I mean, I suppose you could kind of say like... You could kind of do that, right? And it'd return... It'd set something to be equal to whatever's in the in pointer. And then increment the in pointer. But then it's kind of like... That's what output car is doing, isn't it? You know, like... You know, I could equally say, like, car... Oh, hang on a minute. I mean... Right. Oh, guys, it's a value. Recurring value. Oh, right. We'll do this since. Okay. Hmm. Oh man, I don't know. I mean, it does feel... I mean, maybe, actually, maybe this is a better way to do it, because you're sort of more cognizant of what they're actually doing. But by the same well, I mean, you do want to know what stuff is supposed to be doing, I think. But I don't know, it kind of feels like it's just another thing to think about. I mean, because I do feel like I understand like what this means. Like, you're going to be writing the count into the... Or you're going to be setting the value at the hourly pointer to be equal to the count. And then increment the count. Album car. So whereas like... I suppose you could do this, maybe. Where's that? 917. So that was just establishing what this does. Where was I? I like how it doesn't. He hasn't caught the shadow variable for some reason. Yeah. Let's try it. Let's give this a go. And just see how it jives. So, where are we? I need to actually if1 this whole thing. Oh, that'll be why. Where's my 0 going to? Where's the end if? It's here. Oh no, all this stuff down here. Oh, it was right. So okay, so all this was if zeroed out. There we go. Yeah, so I don't actually need this if one anymore, I don't think. Either. Well, let's keep it there for now. So, set that to be equal to the token. Token is equal to the value of its in pointer. But then again, here we've got car token is equal to in pointer, so we might as well be saying at this point output car to the token, right? Oh wait, well that output car is going to increment the in pointer though, isn't it? Do I want that? I think. In pointers at the start of the in buffer. Oh, hang on. How does this work again? Output car, it's a void. Alright, so you can declare the token. And then do I was going to cancel the counter on its own, wasn't I? Yeah, is that good? I'll tell you what, let's see if this is doing what I expect, right? So I need to do it as arc, so I don't know. Right. So if I go down to this output car call, just run to there. So at this point, the value in the in pointer is n. The value in the token is nothing. I'm going to step over this, and the token is still nothing. That's now an H. I think I'm going to try to do hourly points plus equals to token. Blimey. Print in buffer. Oops. So that's nothing. So in, right, okay. Why is that nothing? Yeah, why is in but why is that nothing? Is in buffer not null terminated? Buffer. So it's going through the BWT encode here. I don't think it is it? No, because we only do that at the very end. For some reason. What is this doing though? It's like in buffer. Where's that if one? So that's my in buffer. That's the first 8 characters of it. So the first character is a 6E. A 6E? What is a 6E? I mean, presumably it's just an N. I don't know, I think I might have to call it a day actually. I'm feeling super lost. Trying to say an operant in buffer after the Apple car. Okay, so it's setting the in pointer to be the value of the token. car. So that means we're going to output the value of the token. Output this character into this address. Now call output car twice in a row. ZZ. Is there another printf somewhere? This guy. What was he printing? The RLE buffer. Oh, was it going through this? No, that was if-zeroed. Oh, it's doing the eat cow. So for some reason, really if-zeroing this little section. So basically, right, I mean, I've already said this haven't I, but it's basically like saying, instead of doing output car, it's basically like saying in pointer. And the output's exactly the same thing. Hello insofar as. Yeah, I don't know. Like, you know, this guy, I mean, obviously it's new to me. And where, you know, whereas this thing is really familiar to me because I've done it quite a bit. Watching John, wow. What was he doing today? I haven't really managed to watch much of his stuff. I think I saw him doing some kind of 3D. Was it 3D or was it like texturing stuff or something? A couple of days ago. What did I actually do today, by the way? He got 3D animation working. Oh, porting code over from the witness to his GI Suckermong. Wow, okay. Porting code over from the witness. Awesome. It's funny you should mention the witness actually, because I have. Where is it? I have a book here in which I've done some pencil and paper witnessing. I think I should be able to show you. Can I show? I mean, would this be at all spoilery? I mean, I can show you. I can I'll cover up the actual solution, and I haven't actually done the solution yet. And that is like no spoilers. So yeah, if you could see any of that, that was like some stuff I did it last night actually. I've just got up to this particular point. And yeah, I just need to write it down. I think I've solved it, but I still haven't implemented this solution. So that's what I'm going to do after this stream, actually. Yeah. Let's just see how long I'm going. Go for an hour and 24. Yeah, I mean, I'm kind of feeling a bit knackered as well, so. Like, I don't even know if I can do another half an hour. And I was kind of hoping it would just be a like an actual 30-minute practice. But I suppose I always hope that. Oh, hang on, it's all in the functions, isn't it? So, yeah, like this guy here, like reader to pointer plus plus. This thing could be changed to use output string. Car, sorry. This one not so, look at that. Oh, that's setting the BW, okay, that's setting the pointer up. What else have I got? These guys are their own thing. Yeah, the decode doesn't even use pointers for whatever reason. Yeah, I don't know. I think I'm going to have to call it there for today, unfortunately. What day is it? Is it Tuesday or Wednesday? Thursday? Oh, it's just gone Thursday, right. It's Thursday already, God. Why is it Thursday? Was it Tuesday that I finished the lesson? Was it, I think? Oh, sorry, hang on a minute. Where are we? I don't even know. I don't even know what day it is. We just had Wednesday. God damn it. Just had Wednesday. And I revisited. So I did the BWT. I did all of this yesterday, right? Why is it Thursday? Should work. I think you're just not whitelisted or something. Quotes aren't needed. Oh, it's my birthday. Yeah. Let's see what birthday it is. So my last birthday was Pi, wasn't it? What could this be? Oh, it's Transistor. In circles. So it'll be 360. So yeah, that's not even. It's not even coming through. Not the actual quote isn't needed. I hope this won't get caught, by the way. I mean, the whole soundtrack is on Bandcamp, so it is playable. I just don't know if the YouTube itself is permissible. Yeah, okay, so let's just have a look at what I did today. So, something funny to tell, that was yesterday. All of this started getting to grips with the output car. Isn't it? Yeah, the printer. Yeah, all of this stuff here is to do with that. And then I wrote out this to sort of do it manually. And I also changed the while loop, didn't I? I changed this to be, rather than being like a 4i, it was like, yeah, while we were within the bounds of the buffer. Seems that'll be correct. I don't think in-buffer's moved, no, it's still there. In point series. So let's, oh yeah, so taking the stats from all yesterday. Oh yeah, then here again I was going to start to do it. Again, wasn't it? Before I actually had to go and understand what these guys do. Yeah, okay. So I'll tell you what I think I'll do is after this track I'll close the stream and then I'll mull over the stuff. So mull over output car and eat car, and also like the old way of the old way of setting values, and also to try and like think about the actual algorithm as well. The actual run length encoder bit of it. And then hopefully tomorrow I'll be able to actually do this. Yeah, do that. And then maybe get onto the test utility stuff, because like the test utility, I didn't even get onto that at all. Basically, the idea of that was it would sort of, well, it would count up how good a job the encoders are doing. So you could like compare the RLE against the BWT, and also against like the original thing. Maybe you could compare like how long they take as well. I don't know. I mean, potentially it could test that I've actually encoded and decoded the correct stuff. But I was more thinking in terms of like testing like how effectively they compress. But yeah, I mean, maybe we'll get that tomorrow. Yeah, I mean, I just need to get this guy sorted out, and then we can do it. But yeah, until then, and I must say actually, it sounds weird to hear myself without headphones on. Like hear myself, like essentially, like just talking into a mic, really. But yeah, anyway, until tomorrow. Thank you awesomely for watching and helping and being patient and being heroic. And until tomorrow, farewell for now.